Okay, hello everyone. Welcome to the SingularityCE community call for August. So today we're going to start off with a demonstration of some vulnerability scanning and supply chain security related work. And then we'll get on to the usual overview of what's going on in development and open questions at the end. Please interrupt at any point if you want to ask something, and we'll get started. The call will be posted to YouTube after this, so if you want to kind of refresh your memory of anything we go through, it'll be there for you later. So the first thing we want to show today is some work that has been done not in SingularityCE itself, but in another project. So there's a project called SIFT, which is led by a company called Anchor. And SIFT is a tool to generate software bill of materials for container images and other artifacts. Now, we've talked about this and kind of shown some stuff before, but Sylabs has been able to work with Anchor now to get direct support for SIFT format image, so Singularity containers, into this SIFT tool. So with SIFT, you can now not only scan OCI or Docker containers, but you can work directly on the Singularity containers too. So the reason this is important is because software bill of materials have been sort of adopted as the entry point to building a secure software supply chain. We've all heard about various attacks where dependencies of software have been kind of replaced with malicious code. And because most projects now have a lot of dependencies, that can result in exploitation quite a long way down the chain. So the idea of a software bill of materials is that it completely describes what makes up your container or your package. It lists the dependencies, their versions. It lists the licenses they're under. Also, if compliance with licenses is something you need to be aware of. And once you have a software bill of materials, you can use it then to identify vulnerabilities too. So SIFT is Anchor's tool, which generates an sbomb. And then they have another tool called Gripe. And Gripe can scan a container for vulnerabilities. And the way it does this is it actually generates itself or uses a pre-generated sbomb, which describes what's in the container, and cross-references it with databases of vulnerabilities. So with support for SIF images now in these tools, there's quite a kind of simple route to integrating vulnerability scanning into a workflow in which you build and maintain Singularity containers. So I'm going to hop over into a terminal quickly here. And let me show you how you do this. So in this directory, I have just a SIF image, which is an Ubuntu container that I've pulled down previously. And what I'm going to do, first of all, is I'm going to use, there we go, the SIFT tool, which now has Singularity support. So we can say Singularity : and list our SIF image to generate a software bill of materials. Here, I'm going from the Singularity image, and my output, I'm asking SIFT to generate in a format called CycloneDX, and the JSON kind of output of a CycloneDX sbomb. SIFT actually supports different formats. We're doing CycloneDX here because it's really one of the main kind of adopted standards for sbombs that have been getting good uptake. So if I run SIFT here, it's going to parse the image. And the work we've done with Anchor uses the SIF Go module behind the scenes to interact with the SIF image and look at the content without needing to extract it or anything. We're actually looking into the squashfs itself. So SIF has cataloged the image, and now it's created this file, this sbomb cdx.json. So if I look at that on its own, we'll see it's quite a kind of complex format, but we can see that it's talking about paths and URLs related to packages and things and what's in this container. Now, that is a great starting point for sort of audit processes. So if you want to inventory your containers, then the sbomb allows you to do that. And you generate an sbomb once when you create the container, and you can go and look back at it through the container's life to see what you have in there. So let me jump up in my history to the gripe command now. So gripe is the vulnerability scanner, and we're going to feed it our sbomb, which we just generated. So gripe can actually scan containers directly, but if you scan a container directly, it has to do the same things as SIF, read the image, and that can take some time for large containers. If we generate the sbomb once, we can then run gripe as many times as we want into the future to see how vulnerabilities accumulate as the container ages. So let's run the gripe tool. And first of all, it's going to check the vulnerability database it has to see if it's up to date. And then it's going to tell us what's up in this image. So it scanned the image using the sbomb, really, not the image itself. And it's reporting 27 vulnerabilities. So this is actually quite a new pull of an Ubuntu container, but we can see there are CVEs which apply to this. If we look at a row here, we can see that we have the package name, the package version that's installed, and we have a reference to the CVE identifier and its severity. And you'll notice that we have things like a vulnerability reported here, which is from back in 2016, but it's a low severity and there's no fixed in. So this is something that the Debian or Ubuntu maintainers have chosen not to fix because of whatever the nature of the vulnerability is. Whereas other ones, we can see there was a medium severity vulnerability in the E2FS progs, and that's actually been fixed in a kind of patch version of this package, which we could update to if we wanted. So gripe will give you this output. You can also use gripe to generate kind of machine readable output and kind of feed that into a workflow to kind of assess the security of containers you're working with over time. Like I say, the convenience of generating an sbomb and then using that for scanning is that you just use gripe quickly to kind of cross-check against a vulnerability database rather than having to scan the entire container again. So that's the work with Anchor on SIFT and the related tooling. This is kind of an example of where we're trying to work with software projects which are over in the OCI ecosystem, but would be useful to be leveraged by people who are working with Singularity. So we're moving more towards SIF being a module which can be adopted and used by other projects and engaging with projects so that this type of tooling can gain SIF support. And we are very appreciative to Anchor, especially Alex Gibman, who gave us a lot of help landing this stuff. Any questions on that, on the demo or sbombs and vulnerability scanning in general? Okay then, we'll move swiftly along to a quick review of what's been happening with development work on Singularity. So if I scroll down in the changelog first, we can see that we had 2 releases in July, which were relatively small bug fix releases. So the 3.10.1 introduced some additional debugging output, which is really actually useful to identify an issue that someone reported for us. Essentially, previously, we kind of wrapped some places where we call external executables such as unsquashfs, or what we call build scripts, in a call to Singularity itself, but we weren't showing the wrapped debug output. And now we have the ability to see all of that. We had a contribution from, I believe, a Debian maintainer or developer to fix compilation on MIPS, little endian machines, which is one of the architectures that Debian is packaging for, but isn't kind of widely tested outside of that. And we also had really just a fix in hidden test code that implied something was supported that was not. So some people have possibly been under the assumption that in definition files, you can, in the test section, use a -c argument here and set a shell to use a different shell. So that's not actually supported, and it hasn't been supported, but we had some test code and some things which kind of inferred that maybe it was. So we've cleaned that up. More on this in a minute when we get to what's happening in the main branch. The 3.10.2, which followed shortly after, added Enterprise Linux 9 package builds to CI, so you can now pick up an RPM which was built on Alma Linux 9. If you're using Alma Linux, Rocky Linux, Oracle Linux, or Red Hat Enterprise Linux 9, you can pick that one up. And there was an important bug fix, and this is something which was noted by the Attainer project when they pulled in one of our changes recently, and we brought across an equivalent fix. Essentially, between 3.10 and 3.10.2, containers generated from OCI sources like Docker Hub had a run script in there where the shell syntax was such that Singularity CE and Pro could process that because they use an embedded shell interpreter, which was accommodating to a certain feature of the code that was generated. But if you tried to run that run script with your own shell, if you tried to run it through bash, then it would fail. So that has been fixed so that our images don't have these problems. The upshot is if you generated an image between 3.10.0 and 3.10.1, it'll work fine with Singularity CE or Pro itself. But if you are trying to just extract it as a root file system and then run it through some other means, some other container runtime, you might have an issue because of that. So that's tidied up, and therefore we'd advise anyone who has come to the 3.10 series to update to 3.10.2 as soon as possible, so you don't have that issue. Any questions on these releases? Okay, on the main branch, looking forward now in development, we went through most of this in the past meeting. We have some work which has been done to make development more convenient from the point of view of our end-to-end tests. And then we've got new features and functionalities. So I talked about down in the release section that we fixed some code that implied this test -c shell construct was supported. Well, on the main branch now, rather than that -c construct, you can put a custom hash bang in the test section of a recipe in the same way you can in some other sections, so that you can specify an alternative shell there. We've talked before about instance stats, some changes to the overlay create and Docker environment variables, which were all kindly contributed by Vsok, Vanessa. The biggest thing to talk about here today is that we've merged in the ability for non-root users to build from a definition file on systems that don't support the -- fake root option. So the -- fake root option in SingularityCE sets up the container so that your user outside the container maps to a root user inside the container. So you're a kind of fake root user, but it also has a requirement of some sub-UID and sub-GID ranges, so that inside the container you can become other users as well, and they map to something under the control of you outside the container rather than the kind of users on the host, to avoid any security issues. Now, it's quite common for systems, especially large ones, not to be able to easily configure these sub-UID, sub-GID ranges for their users. It's getting better with Red Hat Enterprise Linux 9 and forward, where you can declare these ranges now in something like an LDAP directory, and the hosts can use that information. But for older systems, it's still a matter of having to deploy configuration files out to each node. So there are various ways of trying to allow builds for unprivileged users without this sub-UID, sub-GID mapping. And there's a pull request where there's actually quite a bit of discussion about this, because each method has advantages and disadvantages. For SingularityCE, we have a number of people who are not able to use unprivileged user namespaces through policy or technical reasons on their systems. So we've gone and taken an approach which is different from the approaches that others have done, such as Aptainer and also Charlie Cloud. And we're using something called proot. So proot, which you can obtain from this site, is available as a static binary. And what proot does is essentially it can kind of give you a entire container environment in user space by emulating a chroot and a change of UID and so on. But we're using it just to emulate a change of UID. So we're using proot to give you a root account inside the container build, which doesn't require user namespaces. And it's doing this with the ptrace functionality of the kernel, and optionally with setcomp filtering. So it's kind of intercepting things you're asking the kernel to do, and rewriting it to kind of fake root access and so on. So proot allows you to now do a Singularity build, and you can build a lot of containers, but not everything, without root and without unprivileged user namespaces. So you can't do a kind of basic bootstrap of a distribution using the own tool. So if you try and do a debootstrap or a yum bootstrap type approach, that's going to fail. But it's not often a problem, because we can usually start with an image we already have, a base image, something from the library or from Docker Hub instead for these kind of base images for distributions. We don't support the pre and setup sections. So in a definition file, pre and setup are sections which actually run on the host before we kind of get into the container root file system. And it just doesn't make sense to kind of emulate a root and try and do some stuff there, because it just really isn't expected to work. We run the post section of the build as an emulated root user through proot, and then we run the test section of the build, if there is one, as a non-root user, which is the same as Singularity test if you run that test section afterwards. Any restrictions you have in the Singularity conf file apply to the build. And like I mentioned, it's based on intercepting things, so there's a performance penalty. And then we still have some caveats that some things may fail if there are operations that proot cannot emulate. Dave, you just dropped a comment in the chat. So you're saying that it's not needed in pre-setup because the files are owned by the original user anyway. So what we've seen is that people actually have written definition files where the assumption is that the pre and setup are running as a real root user on the host, right? So yes, the files in the container to root are owned by the original user, but pre and setup aren't just about manipulating those. They can also be about bringing stuff in from the host or doing stuff in from the host. And we've seen kind of weird behavior there. On the whole, we don't actually like these pre and setup sections being able to do stuff on the host. It's arguably kind of something which is there for historic reasons. So this is why we've kind of not put much into making this work with proot, because we can't guarantee everything will work there. And we're trying to give guidance which will avoid sort of random failures. So we would rather say that you shouldn't use those if you need to support this type of build, rather than some stuff working and some stuff not. So anyway, if you try the main branch and you have proot available on your system, you can do a Singularity build as a non-root user, and it'll warn you that you're going to be using proot and things may fail. It'll tell you that if things do fail, try and do a remote build or a fake root build instead. But for simple things such as just taking an image and adding a package, often this is suitable. And we'll be refining this more over time. Any questions on this one? Okay, if I jump across to the pull requests which are ongoing here, the only other thing to mention is that there are two open here which really date back to an extremely old bug or regression. So what we have here in Singularity 2, there's a bootstrap history directory in a container. So if you build a container image which is based on a previous Singularity container, the prior definition file is moved into this bootstrap history directory in the image. Now, in Singularity 3, when things were rewritten in Go, this was ended up gated behind a conditional. So it only does that if you're using the update flag on a build, which is really about having an existing container running another build over the top of it. And obviously keeping a history of what was there before makes sense in that time, but it also does make sense if you're taking an existing image and you're creating a whole new container. It's interesting to see what the existing image was, what was used to make that. So we had an issue report, and if we kind of follow this back a little bit, we can actually see that this was originally reported back in 2019. This was something from the 3 series rewrite that kind of fell through the cracks. But this is now being addressed through a pull request, which is marked to go into the main branch and also backport for the next 3.10 release as well. Right, I've done a lot of talking, so any kind of questions about the development work that's ongoing or anything else at all, open the floor and we can just have a chat about whatever topics people have on their minds. Okay, looks like it's going to be a quiet one this time round. We will give you back the half hour then. I am not going to be hosting the next one of these meetings. We'll have either Mike, Adrian, or Adam from Sylabs will pick it up next time, as I'm going to be relocating across the Atlantic Ocean during that frame. So I look forward to seeing everyone else in October, but watch this space for the meeting announcement and so on for September, where you'll have a different host. Thanks for joining, and we'll post this to YouTube this afternoon.